Hello children, welcome back to the physics class. I hope and trust that you're all safe and healthy and you are using your time properly. So this is our seventh video session and so far we have completed two chapters and we are in the third chapter and the name of the chapter is sound. Seventh chapter in your textbook. We had two sessions based on this chapter. What did we discuss so far? We'll just have a small recap of whatever we have discussed on this particular chapter in the past two sessions. We started with the characteristics of sound like amplitude, wavelength, frequency, and so on. We learned the meaning of each word and how we calculate them, and we learned about the velocity of sound, how it is calculated with the help of frequency and the wavelength. Then we learned that sound is a mechanical wave, and we discussed about transverse wave and longitudinal wave, and then we saw the differences between the light wave and sound wave. Though they have similarities, they also have certain differences among them. Then the laws of reflection of sound is very similar to that of the laws of reflection of light is what we saw. Then the conditions and the applications of echo. Then later on in the second session of this particular chapter, we discussed about vibration. It is vibration which is the reason for the production of sound. And then we learnt about the types of vibration. The types of vibration are natural or free vibration, damped vibration, forced vibration, and then resonance. Resonance happens when the forced frequency of the forced vibration and the natural frequency of the body matches. When there is a match in these two frequencies, there is a high amplitude sound produced, and this is what we call as resonance. So this is what we have discussed so far in this chapter, sound. And here is a very good news for you. The ICSE board has reduced your portion because of this pandemic condition, and we are not able to have regular classes for a very long time. But don't be very happy, they haven't reduced much. They have reduced here and there small portions in almost every chapter. So I'll be telling you where they have reduced whenever we happen to encounter that particular portion of the lesson. So what are we going to discuss in this video session is the characteristics of sound and the factors affecting the characteristics. So far we have completed 7A and 7B, and 7C is for 7C has almost 6 pages, but here they have reduced the 7C. In 7C, out of all the 6 pages, you're only going to learn the definition and the factors affecting the characters of sound and nothing more. No, we won't be learning much here except the definition and factors affecting, and only these are included in your syllabus for the academic year 2020 to 21 due to this COVID condition. Okay. So before we could go into the particular topic, characteristics of sound, we will see few properties of sound. What are the properties of sound? Sound can sometimes be louder or softer. When a person is, imagine that you're sitting inside a classroom, and when a teacher is asking you a question, your answer has to be loud. And the person who's sitting near you may be a friend and who's trying to help you in telling you the answer will be very soft. So you have a loud sound and a soft sound. When you whisper, it is soft, and when you shout, it is loud. And then the sound can be of high pitched and low pitched. For example, you can compare the sound or a voice of a man and a woman. A man's voice is considered to be a bass voice. So they have a very low pitched voice, whereas women, they have a high pitched voice. And then comes the third quality, whether it is a music or a noise. When we speak, we don't put our speech into either music or noise. So we'll just categorize it this way: whether what you hear is a pleasant sound or an unpleasant sound. So you can categorize or differentiate sound into all these um criteria. So what are the criteria? It could be loud or could be soft. The sound could be a high pitched or a low pitched one. It could be pleasant or an unpleasant sound. So based on these exact qualities, we are going to learn today's chapter. So when your voice is loud or soft, you simply put it in one word as loudness of sound. So here, the three characteristics of sound are: the one is loudness, second is pitch, and the third is the quality of sound. So this loudness goes all the way here. Your sound can either be loud or it could be soft. And the sound, there is a difference in every sound because of the pitch. You can differentiate pitch, whether it is a low pitched or a high pitched sound. And the third one is the quality of sound, whether it is a pleasant one or an unpleasant one. Even if it is a pleasant one, there are certain things that we will be learning in quality of sound. So quality of sound not only belongs to the pleasant or unpleasant category, it can even be applied only in the pleasant sound category, that is even in the case of music. So this is what we will be discussing about loudness of sound, pitch of sound, and the quality of sound. So what is loudness? It's nothing but amplitude. I told you earlier what is amplitude. In this waveform, you are able to see that the wave has gone all the way up here and all the way down here. But whereas here it is a very small amplitude. The small amplitude sounds are soft sounds, whereas the large amplitude sounds are the loud ones. So the loudness is based upon the amplitude of the sound. And here pitch. What do you mean by frequency? Number of waves in a unit time. So if I am going to consider this as my unit time, here I have only one wave, and whereas here I have two waves. So this is a low frequency sound and this is the high frequency sound. So pitch is somehow related to the frequency of sound. And the third one is called as the quality or timbre. So quality of sound depends upon the waveform. So we will be learning in detail about all these three, but not much, only the definition and the factors affecting these three characters. So we'll move on to loudness of sound. What is loudness of sound? The loudness is the character of sound by the virtue of which a loud sound can be distinguished from a faint sound, both having the same frequency and the same waveform. So when you listen to the definitions, you just write it down so that it will be easy for you to compare and learn. So here, the frequency and the waveform can be same, but what can be different? The amplitude will be different. So the loudness totally depends upon the amplitude of the vibration of the vibrating body. So if I shout louder, I give a loud sound. But I have a pitch, because though I'm talking through this video, you can imagine that me talking, because you know my voice, you're very familiar with my voice. My voice have a fixed frequency and a fixed waveform. So my frequency and waveforms are different, but my amplitude can vary. If I talk loudly, and I can also talk softly. So this is how you characterize loudness. Here frequency and the waveform can be same, but amplitude varies. When amplitude increases, it is a loud sound, and when the amplitude decreases, it is a faint sound. And now let's move on to the factors that are affecting the loudness. Number one, the first factor that affects the loudness is the amplitude, like I told you. the amplitude. When the amplitude is high, you give a loud sound, and when your amplitude is low, you give a very soft sound. The loudness is also affected by the distance. How is it affected by the distance? When two people are standing close nearby and when they talk, even when the amplitude is low, you will be able to hear it well. But when the people are away from each other, if your amplitude is low, you will not be able to hear it. Even when you increase your amplitude a little, that person won't be able to hear. You will have to increase your amplitude a lot so that the person who is standing far away can hear, which means your loudness and distance are directly proportional. In order to increase, when the distance increases, the loudness will decrease. So you will have to increase the loudness. So I'm sorry, the loudness and distance are inversely proportional. When distance increases, the loudness of the sound decreases. Whereas here, when the amplitude increases, the loudness also increases. So here, the amplitude and the loudness are directly proportional. Here, the distance and the loudness are inversely proportional to each other. So we'll move on to the third factor. The third factor is loudness and the area of the vibrating body. Here you can see different sized drums. Each drum has a different area of vibration. If this one has a very small area of vibration when compared to this one. So they have different area of vibration. So when you bang on this drum, so banging this drum will produce a sound which is very less when compared to banging this drum. So loudness is directly proportional to the area of vibration. So when the area of the vibrating body decreases, the loudness will decrease. When the area of the vibrating body increases, the loudness will increase. I believe you are familiar with this proportionality sign. Directly proportional means when one increases, the other will also increase. That is called directly proportional. Inversely proportional means when one increases, the other will decrease. For example, you have a plate full of food and your stomach. When the plate becomes empty, your stomach becomes full. So the food in a plate decreases, your food in your stomach increases. So one decreases and the other increases. That is directly proportional to each other. Whereas in the case of your studies, the more you learn, the more you get mark. The amount of time you spent in learning will be equal to the mark that you score. So the more you learn, the more you get marks. So the learning process and the marks that you score are directly proportional. So we'll move on to the next one. Loudness and density. So here in this table, you are able to see the material and their density. And this is the velocity of sound in that particular material. So when you look at water has the, okay, we'll move on to air first. What is the density of air? The density of air is 0.00139. In air, the velocity of sound is 331. Now we'll move on to copper. The density of copper is 8.9 and the velocity of sound in copper is 6420. So what is happening here? When the density of a material increases, the velocity of the sound increases, or you can also say the loudness and the density of the medium are also very similar to this. The more the density, the more the loudness of the sound. And then we know what resonance is. Resonance is when the natural frequency and the when the natural frequency of the body and the forced frequency matches, there is an increase in amplitude. So whenever there is an increase in amplitude, there is going to be an increase in the loudness. So here, loudness and density are directly proportional to each other. So here they are directly proportional to each other. loudness and resonance are interconnected, because wherever there is a resonance, there is a higher amplitude, and wherever there is a higher amplitude, there is loudness. So we'll move on to the next character of sound. The next character of sound is pitch. Pitch is that characteristic of sound by which an acute note can be distinguished from a grave note of same loudness. Okay, I'll just tell you what is meant by acute and grave first. The word acute means a shrill or a sharp sound, whereas the grave note means a dull or a low sound. For example, I'll just try to give you some sound and try to find the difference between them. Okay, by now you heard two different notes. One acute note and one grave note. This is your acute note. A sharp note or a high note, a shrill sound. Whereas this is a low note and you call it as a grave note. So a pitch, here in this, the loudness of both the notes were same. But what was different? The pitch was different. It is because of the difference in pitch you are able to differentiate the notes. So what are the factors that are affecting the pitch? So when it comes to a stringed instrument, so we will be always discussing about percussion instrument, string instrument and a air instrument. Sorry, wind instrument, right? So in the case of any string instrument, it is the length of the string that affects the pitch, which means the shorter the length, the higher the magnitude of pitch. And then the thickness of the string. If it is thick, you will have a low pitch, and if it is thin, you will have a high pitch. Tautness, that is the tightness, how much tension it is. So the more you tighten the string, the better pitch you get. So for all these three, imagine you don't have to have a guitar in your hand, you just have to have a rubber band. Take a rubber band, and when you play, initially if you keep it short, or maybe you can stretch it a little bit, and if you try to play, you will have a high, you won't have very good sound to listen at. But when you stretch it more, what will happen? It will become very thin. So when it becomes very thin, you will be able to hear a proper sound and a high note. When you reduce the length, what will happen? The tension decreases. So when the tension decreases, what will happen to the pitch? The pitch goes down. And when it comes to the length of the air column, in all the wind instrument, you might have seen having some holes here and there. And if you could note it well, there are different types of flutes, and the length and the thickness of the flute will differ. That's because each flute will give you a different pitch. So it is the length of the air column, the thickness of the string, the tension, the tightness of the string, and the length of the string which affects the pitch. But what actually happens here, or on which does the pitch depend upon, is the frequency. The pitch and the frequency are directly proportional to each other. The more the pitch, the higher the frequency. But pitch is not as same as frequency. Don't imagine that pitch and frequency are same. Pitch depends upon the frequency, and it also depends upon the ability of the listener. It also varies with the person who listens to the sound. So when it comes to pitch, all that you have to think of or to remember is, pitch is you can hear a sound with the same loudness, but what changes? Their frequency changes. So due to the difference in frequency, you hear an acute note or a grave note, that is a shrill note or a flat note. And this pitch, it depends upon frequency. So the more the frequency of the wave, higher is its pitch, and less the frequency of the wave, lower is its pitch. So we'll move on to the third quality. Quality or timbre. Quality of a sound is that characteristic which distinguishes two sounds of same loudness and same pitch but emitted by two different instruments. Okay, so far when we were learning about loudness, we saw that two sounds of same frequency and same waveform but different amplitude. And when we were learning about pitch, we saw that the loudness is different, the loudness is same, but the frequency is different. That is, the amplitude or loudness is same, frequency is different when it comes to pitch. When it comes to quality, what is same? Here the loudness is same and the pitch or the frequency is same, but you will be able to find that if they are coming from two different instruments. So just listen to the sound that you are about to hear now. Both these sounds had the same loudness and they had the same pitch. But I'm sure by now you would have identified what are the instruments that it came from. This sound is from a guitar and this sound is from a drum. So both the sound have same loudness and they had same pitch, but you are able to differentiate the sound and you are able to find that they are coming from two different instruments because they have a different waveform. So what is a waveform? We'll see that now. So here you know that this is a waveform. This waveform changes for every single instrument. All these four waveforms have same frequency, they have same amplitude, that is their pitch, and their loudness are same. But what is different? Their waveform is different. It is because of this difference in waveform, you are able to find which instrument it comes from. See, the waveform of a violin and the waveform of a person singing is very different. And here the tuning fork always gives us the ideal waveform because I told you it has only one frequency. So what actually is the reason for these different waveform is every sound has a combination of frequency. Maybe I am playing a guitar. Even when I play a guitar, even if I am playing a single note, even this single note will have a combination of frequency. So it is because of that I have a waveform like this with all ups and downs, which means they have a wave. This wave is a combination of different frequencies. I remember telling it to you very clearly when we were discussing about tuning fork. It is the only instrument that produces sound with a single frequency. No other instrument or a human voice can produce sound with a single frequency. It is always a combination of frequency. And it is because of this combination of frequency, what happens? The waveform changes. The pitch is same, the loudness is same, but the waveform is different. So it is because of this difference in waveform, we are able to distinguish the sound that are coming from different instruments or from different people. So we'll just have a small recap of whatever we have learned so far. We learned about loudness, then we learned about pitch, and then about quality. Loudness depends upon various qualities like distance, amplitude, density of the medium, and resonance, and the area of the vibrating column or the area of the vibrating body. And then we learnt about pitch. Pitch is nothing but a sharp and a flat sound. And this totally depends upon the frequency of sound. And the third one we discussed about is quality. Quality of sound, it simply doesn't mean that, wow, it's a very good music and it's a bad music, it's a pleasant sound or an unpleasant sound. Even in the case of a pleasant sound, every instrument produces a different waveform. And with this different waveform, we will be able to find that it comes from what? And what is the reason of this waveform? Every waveform is a combination of frequency. Every instrument or the voice that we produce or the shouting of an animal, everything that we hear, it's a combination of frequency, and the only instrument that produces sound of single frequency is the tuning fork. So children, with this we are completing the 7th chapter. I'll drop down the notes in your Google Classroom, and I request you to finish your classwork. For this, I didn't give you any assignment for the previous video because I thought it would be better if we could finish the lesson, and if it would be easy for you to submit the entire classwork. And I'm going to give you another assignment. The other assignment is, so far we have completed 3 chapters. I want you to write down all the formulas in all the 3 chapters. Put chapter 1, write all the formulas. And then chapter 3, write all the formulas. And then chapter 7, write all the formulas. I'll put a separate assignment page in the classroom for submission of formulas alone. So what you're going to do is, you're going to write the formula for all these 3 and submit. And when we were discussing about in the first video of the 7th chapter, I asked a question in the middle of the video session, and there was one, the first person to give me the answer was, I think it was Padmashri. So now I request you all to respond in the WhatsApp group and tell me what are the difficulties you face and how well you're able to understand. Because I tell you again and again, if only you respond, the teachers can change their style to the way which will be useful for you and satisfying for them. So make sure to clear your doubts now and then, submit your classwork and use your time well. May God help you to understand well, and may God fill you with the wisdom from above for better learning. And again, I would like to tell you, don't waste your time and use it well. Thank you, children.